Chapter 2 is a chapter about graphing the solutions of an equation. What do we mean by this? Well, let's start with an example. And suppose I'm asked to graph y equals 2x minus 3. What we mean by this is we want to illustrate on the Cartesian plane all solutions of this equation. So in the Cartesian plane, this is x and y. I want to illustrate all points which are solution of this equation. So for instance, right, with a table of value, I can start to recover some solutions. If x is 0, for instance, if I replace x by 0, I can see that y needs to be minus 3. So that's one of many possible solutions. If x is 1, I can see that y, which is 2x minus 3, right? Y is 2x minus 3. So 2 times 1, 2 minus 3 minus 1. So that's another solution. So 1 minus 1 is another solution. And I keep going like this. X is 2. Y is going to be 4 minus 3. It's going to be 1. So at 2, we're in 1. Maybe I want to go backwards. X is minus 1. I'm going to get minus 2 minus 1 minus 5. So at minus 1, I'm at minus 5. I'm down here. So I've got many solutions, but I'd like to get them all, right? And clearly with a table of values, maybe I think all solutions are part of a line. Maybe that's the case, but maybe actually I'm wrong. Maybe there's a solution right there, okay? Then how would I know if it's right or not? How would I know if? So it seems right now that all my points, they are lined up on a line, but is that true? How do we know? Unless maybe we're told before. In fact, it's true. They're all part of a line, but how do I know? How do I know there isn't a point out there that's not part of the line and that's still a solution, right? So with the table of value technique, table of values, it won't guarantee that I have all possible solutions. And in fact, at some point later on, we're going to be graphing things that look like this, right? So if we start putting points, like, it's going to be very difficult. If I give you these points, like, can you find the curve that goes through all these points? There aren't really many curves that do that, actually. I could just come up with my own curve, okay? But maybe you can come up with your own other curve, I don't know, okay, like that. So clearly, with a table of values and graphing those points and trying to link them with a curve, it's not going to work very well unless the equation is a line, but then I need to know that it is actually a line. Okay, so before doing this, maybe a few more things. This point here, it's kind of important. It's the point, like 0 minus 3, where we're crossing the y-axis. So this point here, 0 minus 3, that's called the y-intercept. This is where we intercept the y-axis. This point here, that I don't have yet, is the x-intercept. It is the point where y is actually equal to 0. So I kind of need to go backwards, where if y is 0, what is the value of x? X is going to be 3/2. Okay, so 3/2 is the point I'm looking for. And it actually shows pretty well on my graph, right? It's halfway between 1 and 2. So this is 3/2, 0. That's called the x-intercept. Okay, so those 2 points are actually pretty important. X-intercept, y-intercept. So let's keep going. I'd like to make sure that I actually have a line. Okay, so how do we know? No, the graph is a line. Well, the graph is a line if See, if I've got a line like this, every time I move by a certain distance, I go up always by the same amount, right? If I go forward by the same distance as here, like if this is equal, I go up by the same amount. So let's say if I go forward by 1, I should be going up by the exact same amount each time I go forward by 1. So let's take a look at what happens here. Say X is increased by 1. How much is Y increased? Right? Okay, let's take a look. So I'm at some value X, okay? X could be anywhere, okay? Now, if this is a solution to my equation, it means that this point is X and Y is 2X minus 3. For instance, like I said, if X is 2, then Y would be 2 times 2 minus 3 would be 1, right? This is what we had at this point here. If X is 1, Y would be minus 1. In general, if X is some value, Y is 2X minus 3. So if I increase X by 1, now I'm at X plus 1, okay? How much does Y increase? I'd like to know how much this is. Well, let's see. Okay, Y, if I'm still part of the, if this point now is part of the solution set, right, of my equation, so part of my graph, it means that it will satisfy the equation. What's the equation again? Y is 2X minus 3. So if instead I replace X by X plus 1, if it's a solution, right, then that's going to be twice the X value. So Y is going to be twice the X value minus 3. So it has to work, right? This has to be satisfied. Y is going to be 2 times X plus 1 minus 3. And let's see how that relates to the previous coordinate, 2x minus 3. So if I expand this, I get 2x plus 2 minus 3. And let's regroup these two together. This is 2x minus 3. That's my previous y coordinate, right? Notice it's right there. This quantity is right there. Okay, plus 2. So this is basically the previous, or the y coordinate at x. Let's write it like that. Y coordinate at x plus 2. So in other words, this, no matter what x is, it increases by 2 each time. So we're really in this situation. We increase by x by 1, we go up by 2. We increase again by 1, we go up by 2. So clearly, I get the equation of a line. Okay. So this 2 here is called the rise. And this 1 here is called the run. So if I have a run of 1, the rise is 2. So this is what I get from this. So when x increases by 1, then y increases by 2. And where's that 2 coming from? It's really coming from doing 2 times 1. So it's that 2 there. In other words, if I have an equation of the form mx plus b, okay, look what happens if I replace x by x plus 1. Well, m multiplies x, m multiplies 1, so I've got this little m there, plus b. I can, like before, regroup mx plus b together. So that's my previous y coordinate at x, to which I add m. Okay, so the value of m tells me what my rise is. So if m is equal to mx plus b, then its graph is a line. So now we're guaranteed that it's a line. Its y-intercept. What's the y-intercept of mx plus b in general? If I've got mx plus b, well, it's going to be, the graph is going to be that of a line. Maybe it can go up or down. But when x is 0, right? If I replace x by 0, y is b. So this guy here, that's 0b. So here b is positive. It could be negative if the line is further down. But this is the y-intercept. So it's, I wanted to write it like that. Its y-intercept is 0b. When x increases by 1, then y increases by m. And this m, we call it the slope of the line. Slope of the line. It's a number that tells me how steep my line is. If m is really large, it means I go up very high for each increment of 1. So it's going to be steeper, right? So this would be, I don't know, slope of 1, right? 1, 1. That's m equals 1 here, a slope of 1. Okay, if m is 2, if I go up by forward by 1, I go now up by 2. M is 2 now. What's the slope in this case? If we go forward by 1, we do not move at all. So m is 0, no movement along the y-axis. If I have something like this, I go forward by 1, and I go down by 1, right? This is a slope of -1. So when it's negative, the line goes down. When it's positive, the line goes up. And slope of -2 would be much steeper. If you go forward by 1, you go now down by 2. Like that. Okay? So now, every time we see mx plus b, so essentially a polynomial degree 1, we are guaranteed to have a line for its graph. And a line is specified by 2 points. So I can actually easily graph the equation of a line by finding 2 points. But I can also use the fact that I know what its slope is and its y-intercept. We'll see both methods. So here, I want to graph y equals -3/2 of x plus 2. So maybe I'll show you 2 solutions. Solution 1, I'm going to use 2 points. Okay, well, any point would work. Actually, if I choose x to be 0, it's very easy to recover y, right? It gives me, this actually gives me my y-intercept. So 0, 2 is a point on this line. And then I could select another point. I know if x is, actually, maybe if I want to work with integers, I could choose like 2 for x this way. -3/2 times 2, that's going to give me -3 plus 2 minus 1. So at 2, 1, 2, I go down by 1 like that. And that's my, so this is 0, 2, this is 2 minus 1. And I just link these two with a line, and that's my graph. Maybe I can identify my axes, x, y. So this is solution 1. Solution 2, I can use information given by the coefficients here. This what multiplies my x, that's my slope. Okay? And this is the y coordinate of the y-intercept, right? When you replace x by 0, you get 2. That's the y coordinate of the y-intercept. So in some books they also actually say this is the y-intercept, but I like the y-intercept to be a point. So the slope here is -3/2 y-intercept is 0, 2. Okay, so what does my slope mean? Means what? Okay, if I go forward by 2, well, actually by 1, forward by 1. Let's do it this way. Forward by 1. There's a minus sign here, which means we go down. So what happened here? We go down by 3/2, right? Because of the minus sign. It's easier maybe to work with integers. If I go forward by 2, I will go down by twice as much, so by 3. That's easier maybe. Okay, let's see. So if I use this to graph my function, I start at 0, 2. 0, 2 right there, okay? And if I read this last sentence, okay, using my slope, I can see that if I go forward by 2, let's go forward by 2 starting at that point, which is the y-intercept, to go forward by 2, I go down by 3. So 1, 2, 3, I go over here. So I would get here. So if I go forward by 2, I'm now at, well, I was initially at 0, 2, so go forward by 2, x is now 2. And I go down by 3, 2 minus 3 is minus 1. So I recover the point I had before. So this is a solution using the slope and the y-intercept to recover the graph of the line.